Okay, so far we learned about the variables, right? About the data type. We said there are many of them, but we focus on the most important one, which are integer, if you remember. So integer accepts only the numbers without decimal, like let's say 14, for example, right here. And then also double, okay, is the one that accepts decimals. For example, I can name my variable val and then assign it a variable that accepts decimal. Okay, so of course I said there are more than this, but this is the most frequently used. Like for example, for integer, there is something called long. Long is like a variable or data type that accepts bigger numbers. I was talking about trillions, for example, or huge numbers. Integer is not enough. It's like a boxes, you know. There is a box for kids and there is box for medium and there is box for adults. It's the same box, it's just the different sizes. And then for double is the same thing, except decimals we have float. Float is like half the size of double. But this is the one we're going to be using frequently. Integer, double, and then also we have char or character, char, or car. It accepts only one single character. For example, I may declare a variable called letter, and I'm going to assign it only one letter. That letter could be space, as long as it is one. Anything from the keyboard is pretty much a character. I can put a question mark. That's a character. Or the letter A. Okay? So that's an example of a char. We have string. So string is a data type. And then, for example, I can put name. Now, what's the difference between char and the string? String accepts one or more characters and it's surrounded by double quotes. So, for example, I can put John Doe here. That's an example of string. So basically a bunch of characters that are surrounded by double quotes. That's the difference. And then also we have Boolean that accepts either true or false. For example, I may create one called pass, either true or false. Or a statement or expression that returns true. For example, I can put a grade, assuming like a grade is a variable that assigned a value, 84. So when I put grade is higher or equal than 70, it's like I'm asking the question, is the grade higher or equal than 70? So the answer has to be either true or false. So in this case, it is true. Why? I'm sorry, we don't use Boolean, we use bool. Okay? So bool stands for Boolean. That means either true or false. So this is an example of a Boolean expression because we have to answer either true or false. Is the grade 70? If I put, for example, 6 here, then all of a sudden it's going to change to false. So if I print it, it's going to print false. So if I put pass, I'm sorry, I put C out. So if I put pass, it's going to put false because that's the value of the variable pass at this time. Oh, but they put 0. 0 is the same thing as false, and 1 is the same thing as true. For example, if I put here 94, so it's going to change to 1, which is exactly the same thing as true. Now let's move on to other things. So today we're going to be talking about few things. Please feel free to ask any questions you want. So let's start with the variable. We said x equals 5. Now there are some expressions, some assignments, some that we use frequently, either to increment our variable or decrement or change the value. One of the most frequently is something like this: x plus equal 2, for example. What does it mean? X plus equal, you will see it frequently. This is the same thing as x equal x plus 2, which means the new value of x is the old value, which is 5, and then add 2 to it. So now the new value of x is 7. If I print, the value of x is going to say 7. It's like I'm updating my variable by adding 2 to the old value. That's exactly what it means. Okay, so let me run the program and see if this is going to give us 7. See, 7. So it's like an empty bag, okay? and then I put 5 apples. Okay, now the total is 5 apples. Now somebody gave me 2 apples, and I want to add them to my bag. So what's the total now? It's 7. See, it's like you are updating the value of my variable. Okay, and the same thing for minus. I can put, for example, right here. Let me put the end of the line. I can, for example, here put x minus equal, 1, which is the same thing, by the way, as x minus minus. That's an abbreviation, shortcut. And also, or x equal x minus 1. All of them, they mean the same thing. You are subtracting 1 from the value of your variable. That's all what it means. So now we said that it was 7, right? So we subtracted 1. Now it becomes 6. So if I put C out, and then I put x in here, it's going to be 6. That's all what it means. Okay? Because I added 2, subtracted 1. Now I have 6 now. Let's say I want to multiply now. I'm going to put multiply, which is the asterisk, equal 3. So what I did, I just multiply 6 by 3. Now it's the value of x now is 18. Why? Because I just multiplied it by 3. So and L. So if I run the program, it's going to say 18. And again, this expression is the same thing as x equal x multiplied by 3. That means the old value of x, which was 6, I multiply by 3, 18. Now the new value of x now, it's 18. So from now on, you need to use the new value of x, not the old value. I'm not going to use 5 here. 5 was the initial value, was the default value, was the starting value. But I made some changes. So you need to be aware of the changes I made. So you know the updated value. So you have to be aware of the updated value. And the same thing also for divided. I'm going to put divided. Make sure that you put forward slash, not backward slash. So backward slash, it means something different. We talked about backslash n, so it means something different. So forward slash, let's say equal, and then be careful that you need to start with the operator first, which is minus equal, not equal minus or equal plus or equal asterisk. That's going to change the meaning. So make sure you start with the plus, minus, multiply, divide first, then put equal sign second. Okay, so if I put this now, what is the value of x now? Anybody?
That would be 9, right?
Exactly, 9. Why? Because the last value, it was 18, right? When I multiply by 3, I got 18. Now I divided by 2, I got 9. See, that's all what it means. Now I add one more. So for example, let's say I put, what does that percentage stand for? If I put, for example, here, 7.
The remainder?
A remainder. So what is that supposed to mean? Okay, let's explain here. This is the same thing as this. That means, okay, the value just before this statement, it was 9, right? If you remember, the value here was 9, right? So now I'm putting 9 mod 7. That's the new value of x. What does 9? It's called mod or modulus. It's called mod or modulus. That's basically the same remainder. It's just like this is the technical term they use. So when I say 9 mod 7, that means when I divide 9 by 7, what is the leftover? So when I divide 9 by 7, I get only 1. 7 times 1 is 7, and I have 2 left over. So this will give me the value, the value of x now will be 2. Everybody get this? So whatever is the leftover, that means when I divide, I look only for the integer, okay? And then I see, okay, how much difference now between now and the old value and the initial value. So we have 2, because 1 times 7 is 7. It's far away, like 2 far away, so it's 2 difference, or 2 left over. So now it is, if I run the program, it should give me 2. Good, that's 9. So 9 mod 7 is 2. Okay, be careful, make sure that you master this, because a lot of, I'm not gonna say it a lot, but many students, they get confused when it comes to the remainder. For some reason, they're not used to it. Even in math, we don't talk about it a lot. I think the only time they talk about remainder is when they talk about in math, especially algebra. That's when they talk about the division, like the long division or synthetic division. That's part of algebra, I think 1 or 2, when they talk about the remainder. That's the only time. But other than that, they don't talk about the remainder. So that's why it's kind of not easy. They get confused with the division. So let me give you some questions, see that you master this. Let's say I have a number here, 19 mod 7. If I want to print this, what do you think I'm going to get? Hold on, give me 1 second. If I put 19 mod 8, what is the answer? What is the remainder if I divide 19 by 8?
3.
3, very good. Why? Because when I divide 19 by 8, what is the integer I'm going to get? Is 2. 2 times 8 is 16. So if you put 19 minus 16, that's 3 left over. So if I run the program, you're going to get 3. Now let me test you again. What about if I put this? What's the answer? Silence.
Would it be 0?
No.
Point
Nice
four.
try. Nice. Oh, no. When you divide 4 by 11, you get 0. But what's the leftover? 4. So I'll give you this so you remember. When the first number is smaller than the second number that you are dividing by, the first number itself is the remainder, which is in this case 4. Because it's confusing. Every time I give my student this type of question, the majority of them, they get it wrong. They confuse it with the division. So here, the first number, which is 4, is less than 11. That's the remainder by itself. Because when you divide by 11, you get only 0. And that means whatever the number you have, that's the leftover by itself. So the answer is 4. Any number that is smaller than what you are dividing by itself the remainder. Because it's easier when the first number is bigger. Most people will figure it out. But when I put the first number smaller, so people, they freak out. They just 0. Most of the time, they just say either 0 or 1. But it's the first number itself. You can see 4 is the remainder. So just be careful about these kind of things. All right, so this is about the expression. If you see this kind of expression, you know what it means, right? Plus equal, minus equal, multiply equal, divide equal, and mod equal. So you should be familiar with this. Now, there is a type of variable that we don't use a lot, but it's very common. It's called constants. It acts like a variable. You declare it or you define it as variable, but at the beginning, in the front, it starts with this const. That stands for const. Basically, this is when the variable does not change at all. It does not change, and if you change it, it's going to cause an error in the program. For example, I may put something like this: double tax rate, and then I'm going to assign it, let's say 0.08. That's an example of a constant. So when I put const, that means there is no way you're going to change the value. And if you do, the program will generate an error. Why this is important? There are 2 things. First, can you see, like, the way I tapped tax rate? It's everything is capitalized. It's not required, but by convention, to make it look different, to distinguish this kind of variable constant from the rest of the variable, we made it. I mean, all programmers, by convention, they said, okay, let's make it look different by capitalizing every single letter. So every time you see it, you can recognize it right away that it is a constant. Now, if I try to change it, I'm going to have a problem. If I put, for example, let's say right here, tax rate equals, for example, 0.10. It's going to cause, can you see it's underlined? You can do that. You can do it. You cannot change it. And then somebody may say, why? What's special about this? Because it saves a lot of headaches. I want you to imagine the IRS, or you are in charge of the IRS, program. And then somebody by mistake, instead of putting 0.08, he forgot the zero, the second zero, I put 0.8. And then he's, working on the Microsoft or Apple or one of the big companies, tax he's filing the tax for them. Imagine how much damage you're gonna cause by changing 0.08 to 0.8. I mean, the company might collapse, may go bankrupt just for that problem that you think, oh, just zero. But you are changing from 8% to 80%. So to avoid this kind of problem, they say, okay, let's make it constant. The program does not allow that variable to change at all. So it is very useful in this kind of situation. Now, the next thing that we're going to talk about is something that make your program much easier to handle by helping you with the calculations. Some of the calculation we make sometimes is like the power. Let's say I have a power. How can I do that? How can I use a very simple expression to use power? Now, before we do that, there is something that you have to add on top to be able to use the following function that I'm going to share with you. So you have to go to the top, and then you add include CMath. That means all the functions that are supported by this package. This package allows us, make it possible for us to use this function. It's like you get help from the program by doing something, especially when something is frequently used and you don't want to waste time thinking about easy way. They said, okay, the program, I'll give you an easy way to do that. For example, let's say I want to type 2 to the power of, or x to the power of 5. Okay, I have x, right? So I want to put this power 2 to the power x to the power of 5. So I have to put either this, all right? Most people will think of this, just multiply by itself that number of times, right? So I don't think it's a good way to do it. I mean, it is okay, the computer will accept that, but you're taking a huge risk, because what about if you get confused and then you miss one of them? Instead of like doing 9, you did 10 or 8. So it's not a good thing. It's not a good programming practice. So that's why the program came up with an easy way to do that, which is power. So if you put just pow, stands for power, you put the exponent, which is x in here, and then you put the exponent next to it, separated by a comma. So this will do the power for you. So if what was the value of x the last time? Was it 3 or 5? I don't remember. But anyway, so when you raise that one to the third power, you get 8. I think it was 2. So 2 to the power of 3 is 8. That's why we got 8 at the bottom right here. Okay. Now, what about if I want to do which again? So here you did not change the value of x. You just printed 2. I mean, if you print x, you still have 2. But what about if I want to change that? Change the power, the value of x to pow x2 or 3. Let's say 3, for example. So what I'm doing here, that means I'm raising x, which is 2 to the power of 3 to the third power. That's going to give me 8, and then assign it to x again. So now if I print x, it's going to give me, what do you think? What value I'm going to get? Let's see. See, now the value of x from now on is 8. Why? Because it was 2, but I raised it to the third power, and I saved it. See, I saved it into x. So the new value of x is 8. We have another one which is very frequently used, which is SQRT. You can tell that we are talking about what?
Square root.
Square root. Very good. If I put 36, what is the square root of 36?
6.
6, right?
That's exactly what you're gonna get. So that's like a normal one, but they make things easy for you when you are doing the program. Instead of wasting time trying to figure out an easy way to do that, you focus on the most important thing, and these details, the program will take care of it. They give you like tools to use. Okay? So remember, we have the power, SQRT for power, for square root. Then also, it will allow you to, let's have like an example here. We have another one also. They're very, very useful. And we're going to have an example about that. Let's say we have two variables, a equals 7, and then a equals 7, and then b equals 12. And I want to know, for some reason, like the highest of the two. Which one is the highest? Sometimes, okay, here it's easy because we're going to say 12. But what about if you get these numbers from the user, you don't even know what they are? How do I know which one to be? It's like I'm going to prompt the user to enter two numbers or two grades or whatever. And then I want the program to tell me which of the two or three or four is higher. Then I'm not looking at them. I don't even know what they are. So that's not easy. So the good news is we have a function for this. It's called max. And then it accepts two numbers, in this case a and b, and it's going to return or print the highest of the two. So of course the highest is 12, so that's what you're going to get, 12. Okay, and the same thing for minimum. I'm looking for the lowest, so you do the same thing and you replace max with min, and then you get the lowest of the two, which is 7. So I may think it's easier, but in some situation, it's not that easy. It helps a lot. Once we go like a little bit further, covering other chapters, you're going to see the benefits of this. All right. Now, my question to you, what about if I have a third number? C is whatever. Let's say 5. How do I know which one is the highest? But remember, this function accepts only two arguments, a and b or whatever, but only two. You cannot, there's no such thing as max a comma b comma c. No. So how can it take advantage of this? Somehow I'm gonna try to, do something so I can still take advantage of this function even with 3 variables. Can you think of a way around it? How about doing it in steps? Let me compare two of them, save it in a variable, and then call the function again using whatever variable you have because you saved, right? For example, let's say I'm going to call it high one. That's going to compare only A and B or B and C or A and C. It doesn't matter. Pick any two. It doesn't matter. So now the highest of the two is saved. That's what the variable is for. A variable is nothing but a storage space. So now the computer knows the highest of the two. I may not know it, but the computer saved the value. And then I'm going to put here highest is, I'm going to put max. What do you think I'm going to compare here?
Start with A and B.
Well, AB I already saved the highest of AB, so I have only C left. So what I'm going to do, I already have this variable, high one. It holds the highest of the first two. So I'm going to compare it with whatever the third variable, which is C. Does this make sense? Because I already saved the value, that means A and B is 12. So high one, if I print it, let me print it so you can see this. If I print high one, it's going to hold 12. Why? Because that's the value of the highest of the two. So I'm going to put here just to show you that variables plays like a very, so it's going to show me 12 because that's the highest of the first two. See that? And then if I print now highest, it's going to show me the highest of the two, which is 12. I'm going to compare it with 5. Of course, 12 is higher. So I'm going to put highest, and then it's going to show me the highest of all the three, which is still 12. Everybody get this?
Yes.
So I'm trying to break it down. Look, if you cannot deal with something complicated, try to break it down into steps. Look, if you have a big box and you cannot, it's just too heavy. What other options you have? Okay, try to find 2, 3 boxes and break them down into 3 smaller boxes. So that's something that you can handle. And this concept, this way of thinking is very, very common in programming. And we're going to learn about it later on. That when program looks so complicated, try to find an easy way to break down into small, manageable pieces. So now what about if I have 4? Let's say I have another one D here. 17. How can I use the same functions, Max, to find the highest of the 4 numbers? It's very close to the one that we just had. Something very close. Who can explain to me the steps we're going to go through before we print the highest of the 4 values? Any idea? Look, don't be intimidated. Don't look. We learn from the mistakes. This is the only probably field where mistakes are good ways to learn. Many times, like I don't even have intention. Sometimes I don't even have intention to explain something, and because one of my students made a mistake, and then that reminded me of something, and I start explaining. That means without mistake, that topic wouldn't even be, in there, wouldn't even talk about it. But because somebody mentioned, he made them, I would say, okay, stop class, let's talk about this. No, I don't even mention the name of the students. I just mentioned the concept that we talk. Okay, this stop, and then I start explaining. So if that student did not make that mistake, there is like a missing opportunity to learn. So here it doesn't really matter. Say anything that comes to your mind. We're not judging anybody here. You just, have that interaction, because if I don't have that interaction with you, then we're going to miss some learning opportunities here. So what do you think if I have 4 variables? What do you think I should do? And take advantage of the variable. Variable is something to save. If you want to save something, use variable.
So will we put the max as D, like high 1D, or no?
Yes, but how can we? Okay, max accepts only 2.
Oh,
So what do you think? So we're going to compare 2 by 2. So compare the first one. We already compared the first 2, right? A and B. So what I'm going to
So
do,
would you do
High
max highest D?
yeah, but let me have high 2 first. So I
So
can compare what and what?
C and D.
High 2 and
C
D.
and D, excellent, very good. D. So now I have high 1
okay.
is the highest of the first 2. High 2 is the highest of the last 2. Now I'm going to put highest, add another variable, highest. That's going to compare what? The
High
highest
1
of
and
the
high
2.
2.
Exactly. Max, high 1, comma, high 2. So that's going to give me the highest of the highest, the biggest of the biggest. So now it's going to show me 17, like that. Now I want you to imagine we did not use this. If we have to use another way, like the F statement that we're going to be learning next week or the week after, it's going to take a long time. Why? Because you have to compare, the computer has to compare A and B. If A is higher than B, then you have to compare it to C and D. Now, what about if A is not higher than B? Is B higher? There's a lot of scenarios, a lot of possibilities. It is much complicated. But when you are using this, it's much, much, much easier. Okay, so far we learned about POW. We learned about SQRT for square root. We learned about max. We learned about min. Now there is another one called floor. So let's have a variable first, and it's going to be double. So double, let's say we got E, that's a variable. And then I'm going to assign it 6.57. So floor and seal, you can tell from floor that we are talking about the bottom. Seal is the top. Any number, any decimal number is between 2 integers, right? Like for example, 6.57 or whatever, 57 is between 2 integers. What are they? Between 2 integers. which are what?
7.
6 and 7. Oh, that's it. 6 is called the floor, 7 is called the seal. So you answered the question. Are 6 and 7. So it's like you are, when you round it down, that's the floor. When you round it up, that's the seal. So if I put seal here, see out, and then I put floor 5 or 6.57, the computer will give me the closest integer that is less than the number. Okay, let me use that and L. And then the same thing for seal is the closest integer, but it's bigger. Seal. We don't use it a lot, but in some applications it's very useful. So 6.57, I'm going to find out what the values. So the first one, floor, is what? 6. And the seal is 7. Because 6.57 is between these two integers. So that's all what floor and seal means. Sometimes you are interested to find the closest integer because you want to do something. Let's say you are buying something, and then whoever the cashier, for example, he does not have any cash. He has only change less than $1. And he said, okay, listen, if you want the change, give me the closest integer, okay? If you spend 19.54 cents, give me $20 because I have only less than $1. So how are you going to use that? You're going to use seal. Seal is the closest integer from that number I have. So the computer can find, say, okay, if you have 20, then I give you the change. If you have more, I'm sorry, I don't know, but I don't have change. So that's an example, about this. That means the closest one, okay? So as I said, we don't use it a lot, but it is very useful. Okay, so everybody understand? Now you have to be careful sometimes if you use what do you call the negative numbers. Some people may get confused. If I put negative 3.23, what is the floor for this one? Let me use floor. When you use, so what is the floor here?
-4.
Exactly, yes. Why? Because -4 is the smallest. Always the smallest one is the floor. And what is the seal?
-2.
-2, that's
Oh.
too far.
-3.
-3, very
Two,
good.
3, yeah.
Because -3.23 is between -4, that's the bottom, and seal is, because -3 is higher, is bigger than -3.23. Now, -2 is far up, so there's one closer, which is -3. Everybody get this?
Yes.
And then also we have the round.
Yeah.
That's the most frequently used round. That's the real rounding, okay? Like that's what you use in math. So when we have like a number grade, let's say somebody, one of the students, he got 69.51. Does he deserve to pass?
Yes.
Yes.
Yeah, we
Why?
have 70, right?
Because it's 70, right? What about if I put this? Let's say some calculations, and then he got this.
It'll be 69.
Yeah, the poor boy is not going to pass, so that's too bad. So he has to repeat the whole class. So it's only 0.01 cents, but round will either pass one or. So can you see the difference between floor, seal, and round? Round is the real one that we use in math, but floor, we always round it down, always. We don't look at the number if it's higher or equal than 5. No. Seal, we always round it up all the time. And round is the real one. That means you look at the number after the decimal point. If it is 5 or up, round it up. Otherwise, round it down. Okay? So that's what. So if I run the program, it's going to give me 70. So he should be passing. Oh, because I changed it to 49. Sorry. I don't want him to fail. So that's 7. Everybody got this? All right. Okay, there is one more, which is the absolute value. So we learned in math that the absolute value is always
Positive.
positive. So if I put -45, it is always going to change. If it is positive, then it's going to stay positive. So somebody may say, why do we need, you have to use this absolute value? Well, there are a lot of situations when absolute value saves a lot of headaches, a lot of coding. I'll give you an example. Let's say I have a program that keep track of the temperature, like in a place, let's say in Houston, in Canada, in whatever place. And then I'm interested, let's say the weatherman is interested to check the highest change in temperature. Look, I didn't say the highest increase. I did not say the highest drop. The highest change, that means it doesn't really matter if it's an increase or decrease. I just want to know what's the biggest difference between any two consecutive temperature, either days or weeks, whatever it is. But I just want to know the highest difference, regardless if it's positive or negative, it's drop or high or increase, it doesn't really matter. I just want to know the huge or the biggest, the largest. So in this case, we're going to use absolute value. Why? Because we are not interested in the negative. The sign is not important. I just want to see the absolute value, how big. If there is a huge drop or a huge increase in temperature, then I just want to know about it because it may mean something or whatever there is. I have to look at it, whatever. So here, absolute value is very important. Why? Because I want to ignore the sign. Sign is not important for me. So this is one of the situation or application you can use. Now I'm going to use one example to show you how we can use this, because these are tools. You have to use them. It's not, I mean, I showed it to you. It makes sense, but are you able to use them in a program? So let's say, for example, I want to prompt the user to enter 2 points. Every point has x1 and a y1, has x and y, right? So 2 points, x1, 1, 1, x2, y2. And I want to calculate the distance between these 2 points. So I'm going to, okay, delete this so I can have more space and see how can we do that. And we're going to use the tools that we just learned about. So what I'm going to do, I'm going to declare my variable x1, y1, x2, y2. X2, y2. And then I'm going to ask the user, so we use CIN, remember? To ask the user input, we use CIN. To display the information, we use Cout. And then I'm going to use X1, or maybe like, prompt the user to enter that first. Cout, enter X1. And then I'm going to save time by just copying this. So I'm just going to copy and paste it. Okay, let me just, yeah. So I'm going to copy this and then get x1, y1. Let me create more space. And then this is for x2 and this is for y2. So x1, y1. Now, does anybody know, or does you guys remember the distance formula? What is the distance formula?
Is it square root of something?
Yeah, I want to know that something.
X squared plus B squared equals C squared?
No, this is the
It's,
Pythagorean theorem.
x2 minus x1
You were
plus
close. You were close. Very good. Yes.
Y2 minus Y1 squared, right?
There we go. So it's square root of x2 minus x1 squared, and this is inside the square, plus y2 minus 1 square. So
Okay.
we're going to try to use this to solve this problem. So x1, y1, x2, y2. Okay. So now the distance, I'm going to create a double distance. I'm going to call it distance. So it says the square root first. So what function I should use?
SQRT.
Very good. See, you all guys paying attention. Okay. And then inside, I know inside the power has to be inside the square root. So I know there is a power plus another power. Because if you look at the formula, it's square root of x2 minus x1 square inside the square root plus x2 minus x1. The entire power is inside. Everything is inside the square root. So that's why I put this parenthesis. That means everything has to be inside. And then I'm going to use power x2 minus x1. That's the base. And the square, I have to put it after comma. This is square. And then I'm going to do the same thing for the other half. We're just going to use the x2 minus x1. So I'm just going to use y1 or y2 minus 1. So I'm just going to copy this because it's the same thing. Should I copy it correctly? So copy and then use it right here. And then I'm going to change it from x2 to y2 minus 1. So that's what the formulas say. Now I have too much space, so I'm going to delete that space. So this way you don't miss anything. So I'm going to go right here and I put them together. So that's the distance formula. So now if I print the distance is, and then I'm going to put this. So that's going to give me, let's find out. Of course, it's going to prompt me to enter numbers, right? So I'm going to put here, let's say enter x1. I'm going to enter 5, 2, 1, 4. Oh, I have 4. The distance is 4. Is that correct? Let me see. x2 minus x1 square, y2 minus 1 square. So let's try different numbers and see. Did we use integer, right?
We use double, right?
Yeah, it's a double.
Double or integer? Oh, for this test. So let's try. Yeah, let's try like different numbers and see if this is, because you know most of the time you're gonna get like a negative like a decimal numbers. So let's see 6, 3, 7, and 1. Oh, so what's the distance? Let's see. Power x2 minus x1. Oh no, see what happened here? Look at the x1, y1, x2, y2. Look, y1 repeated twice. So there is something wrong. I know, I can tell. Because okay, maybe the first time it was by accident, but not all the time. So that's why I made a mistake. I did not change it. So I'm gonna put here, let's say 5, 2, 1, 4. There we go. That makes sense. 4.47214. Now I can use the round. Let's say I'm interested. I'm just want to round it. So I'm gonna do this. Make sure you have end line. And then I'm gonna print out. Round. Okay, I'm sorry. I don't have to add one more. I'm just gonna put it right here. Right here, I'm gonna put round and make sure that you put the parentheses and the variable should be inside the parentheses like this. So now 4.47, that's 5. So I should get 5. So that's 5, 2, 1, 4. I should get 4 because 4.47, if you round it, you get 4. See that? Because if it was 5 and up, then it will round it up. All right, everybody got this? So that's how we use it. Okay, we have to put them into practice. You have to know how to use them, because knowing the tools is one thing, but you have to apply them. How can we put them into practice? Okay, any questions about this?
Yes, I have a question. So
Yes.
whenever you use round, will it only round to a whole integer?
Yes, the whole integer. As you can see,
Okay.
I got only 4, nothing.
Right. Where
Yes.
would you be able to get it to round to like maybe 2 decimal places?
I'm glad you asked this question because that's the next thing we're gonna learn.
Oh, okay.
Oh, thank you. All right. So you know, sometimes like when you print something and then they don't look aligned, and sometimes you ask, is there any way I can do to make sure that this information, this data, look like a table? You know, sometimes you want to look at the table. It's like we have a column, everything, all the numbers are aligned, all the population, let's say, are aligned, all the names are aligned, and then all the information. So that's what we're going to build. So let's say we have 4 variables, A, and then I have, and then the problem is they have different number of digits. They don't have exactly the same number of digits. So how can we make sure? So let's say this one has 3, 4, 1, 2. So has how many digits? 6. The first one has only 4, but you still have to align them. So C, and then this one has only 3. And then I'm going to put D equals this number. So how can I align them? So they look like, they look like, it's like an invisible table. So what I'm going to do, I'm going to put C out. I'm going to put something called set W. So set that, but before we do that, there is something also that we have to add. I know sometimes we include some files. We call them header files that we have to include them. We call them preprocessor directive. That's the name, the technical term. So sometimes you have to include this to be able to take advantage. See, it's underlined. That's because you need something. Something is missing. So we're going to use IO manip. I mean, of course, you're going to be using them a lot, so you're going to remember IO manip, as you can see. So set W, what does set W? That means set the width. It's like every number or every column, I'm going to give it a certain number of spaces. It's like when you go to a computer lab and sometimes you see 5 computers and they said reserved. Or you go to the restaurant, this table is reserved. It doesn't matter how many people show up. They said, no. These 10 tables are reserved. Well, okay, but there are some, nobody's sitting there, only 2 tables. It doesn't matter. They reserve the whole thing. That means nobody's going to get to that area. That's exactly what we're going to be doing. So we're going to put set W10. That means the first number will have 10 spaces. Even if you have less than 10 digits, you still have these spaces. No other number will overlap with that number. I will show you how it works. So let's assume that we have 2 columns, okay? 2 columns of numbers. So the first one, 10 spaces, and the second one, I want you to imagine there is an invisible table. The first one take 10 spaces, and the second one 10 spaces. So I'm going to do the same thing. So for the first one, I'm going to put, I can put the first number, A, and then the second one, I put set W 10, and then I'm going to put here B. And maybe like put, end of the line. And then, okay, this is only for the first one. If I try to put it, let me see if what I'm going to get if I run the program. Can you see like it looks like there's a table, invisible line? Can you see like there are some spaces in the front? Why? Because I reserved 10 spaces. They use only 4, but there's 6 unoccupied, just like the reservation. Remember, it doesn't matter, they're coming, or maybe later on, or maybe I may change that number later on to now 7, 8, 9 digits, but they're reserved. The same thing for the second one, there are some spaces. Okay, so now if I try to do the same thing for the second one, so I just have to copy, and then I'm going to do this right here, but I'm going to use this case, I'm going to use CNT. It's still going to be aligned exactly the way it is. So they look much better than if you don't use this. Then they look like, sometimes you can even tell which number is. See that? Regardless how many digits you have, why? Because you reserved a certain number of spaces for this category or for this column. It doesn't matter. Okay, you have 10 spaces, and the other one also 10 spaces. You may add more depending on how big the numbers are. Okay, now to answer your question about the decimal, we can deal with the decimals also. So let's say I have this decimal. Let me use on this one, right? So I'm going to put points. Of course, I have to change them to double, right? Otherwise, it's not going to work. And then I'm going to put some decimals here. Let's say 0.98. And some of them, they have, they have more than, let's say they have 4 digits or 4 decimal points. And then this one has only 1. And this one has 3, let's say. But still, I wanted them aligned. And also, I want to make sure that the decimal also are aligned. And I want only 2 decimals. I don't want too many decimals. So I'm going to put C out fixed. Okay, what does fixed means? There are 2 ways to put the number. Either scientific notation, probably that you are familiar with, scientific notation, or the normal one. Normal one, we call them fixed. Like when you have point and then normal way we put numbers, it's called fixed. And there is a scientific, like when you put that e, whatever, negative 3 and 4 and stuff, when you put the exponents, we're not going to use that. So here I'm going to set the precision. That means how many decimal you want to put. I'm going to put 2 decimals. So this will make sure that now the bottom one will devote, will allocate the spaces for me, and the one on top, the one that fixed sets precision, will format the number itself. That I'm not going to go beyond 2 decimal points. If I run the program, you're going to see that now everything is aligned. Can you see that the first one you have 2, it doesn't matter how many decimals you have, but you set the precision to 2. So they're not going to go beyond 2. That means, of course, they're going to be rounded, but you're not going to go beyond 2. And they're at the same time aligned because of the set W. So set W will allocate the spaces, and then set precision decide how many. If you want 3 decimal points, just put 3 in there. If you want only 1, that's fine. So this is just to, to make sure that your numbers, everything is displayed properly. So it looks like a table. Okay. All right. Any questions about this? Of course, this comes with practice. They said use it or lose it. If you don't practice something, even though you know it, but if you don't use it with the time, you may tend to forget it. Okay, well, probably you may remember some and forget other stuff. So it's good to practice it, okay, whenever you get the chance. Now, there's only one thing. Do you have any questions about the programs?
Does it count the decimal as a spot, as its own individual space?
The dot does not count.
No, okay.
Only the numbers, yeah. For example, here for 57, we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 2 more spaces in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't think it counts. I may be wrong, but let's okay, to make sure if we put 10 exactly, they're gonna, so they're gonna be side by side, right, with no space in between. Let's try it. Just to make sure. I don't think it counts the dot, but I may be wrong. So let's say 2, 4, 6, 7, 8, 9. Like for example, this one B, which is the one that starts with 3. So let me try to use the 89 and then get the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then see if it's going to be. So, okay, we have 10 in there, and then 1, 2, 3. Okay, since it counts only, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, what about the other number? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to add 2 here. So we have also 10 for each. So if they are side by side with nothing in between, that means it does not count. See, that means it does not count, the dot. Why? Because I put 10 and 10, and look, you can even tell them apart. Why? Because there is no space in between. So to answer your question, yes, it does not, the dot does not count.
Okay, thank you.
Welcome. Some of these questions, sometimes, even though probably you heard this before, but sometimes you are not sure. Oh, does it count or not? So it's good to try. Okay, now one of the questions I asked you, do you still remember the programs for, I think the majority of you did figure it out, which was to change the number of seconds to minutes and hours. Do you remember that?
Was it this week's homework, right? Or assignment?
That one's due
Yes.
tomorrow. Yeah.
Yeah, that's tomorrow. Yes, you're right. But many people did figure it out. So I'm gonna give you something similar to that, just to test your understanding. It's gonna take me probably 5 minutes. Okay. I want to ask you a question, and then the answer would be easy. I'll tell you what do you need to answer the question. That means you don't need that much. Let's say we have a number, this 3, 15. Okay. I want a program. Listen to the, oh, I'm sorry, I didn't even give it a number. I'm gonna call it X. Let's say I want to create a program that adds up all these digits, the 3 digits. I want to add them up. That means 3 plus 1 plus 5, that's 9. So when I run the program, it should give me the total of all the sum of all the digits. What do you think I should do? How can I do that? How does the computer access every single individual digit? Because you cannot add them up unless you isolate them, right? You have to separate them somehow. How can I do that? Do you have any idea how to do that? Let's start, okay, step by step. How can I access number 5? Let's say I want to access number 5, or what kind of operation, if I do it, is going to give me 5 so I can save it in a variable called first digit from the right. What operation? If I put x, what? And by the way, you're going to use only two, either this, the division, or the remainder. That's the only thing you're going to be using. I'm trying to make things super easy for you. So what kind of operation, if I do it, I'm going to get 5, starting from x. Divide by something, or use the remainder.
Oh, wait.
One of these two, no more. You don't have to think like too far.
I guess remainder.
Okay, okay. What's the number if I divide by the
310?
remainder will be 5?
10.
Very good. 10. See? Guys, you are smart people. So this
10 or 310?
Yes, because when I divide by 10, the remainder is 5. Okay, that's taken care of. Okay, now I saved 5. I'm going to add them later. I just want to isolate them first. I want to separate them. How can I get number 3? I'm going to call it third, because I want to leave one till the end. Okay, what shall I do? Either using division or remainder. If I do it, then I'm going to get number 3, and then I can save it in my variable third. And keep in mind that when you divide an integer by integer, you get only the integer. That will make it even easier.
Divided
so
by,
divide by what?
By 2.
If I divide by 2, I'm going to get what? I'm not
3.
going to get 3. No. If you divide 315 by 2, that's going to give you 160.
Oh, okay. Oh, I thought we were talking about the 5.
No, I just want the 3. The answer has to be 3.
Okay.
Divide by what?
105?
1. Oh, you were close. Remember, integer by integer is integer. So if I divide by this, or
100, right?
very 100, because integer over integer is integer. So this will give me 3. Period. Remember, it ignores the decimal. That's it. And remainder is 15, right? The remainder is 15. Okay, I'm not interested in 15. I'm just interested in 3. Now, what about the third one, the second one, which is number 1? How can I save it? What operation I have to use to get 1? It may take 1 step. It may take 2 steps. Because 1 is in the middle. How can I get rid of that 5? So I can get 31 first, then use the remainder like the first one. How can I eliminate that 5? By dividing what? X by what? So I can get only 31.
31.
By 10?
By 10, very good, guys. I told you. You are very, very smart. So, okay, now I got 31, okay? This is 31. Now, what shall I do to get the 1? Like the first one, what did I do?
By 1.
No.
Just get the 31. Oh.
Okay, x divided by 10, I'm going to get 31. Now, forget about 5. 5 is not there. How can I get that 1? Remember what we did with the first one? When we get 5, what do we do?
The remainder?
Remainder, exactly. So that means I got x divided by 10 will give me 31, and 31 mod 10 will give me that 1, that the first digit that I'm looking for. So now I have all the 3 digits. Now I can add them up. I can put the total, or I'm just going to put first plus second plus third. It should give me the total. So now if I run the program, it should give me 9. That's exactly what I'm looking for. 3 plus 1 plus 5. So this is to show you the importance, the significance of these tools. Division, remainder. It solves a lot of problems that sometimes you may not even, aware of. Okay, everybody get this? So try to use them, try to practice them, try to apply them, because I'm telling you, like most of the exams, whether for certification or for interviews for job, they ask this type of question, remainder and stuff like that, because it's very, very common. Very common. It solves a lot of problems. Okay. So any other questions before we conclude?
This will be like similar to game like the seconds, like the hours and minutes, and basically, right?
Yes, because remember, like when you convert to minutes, you have to use division, like you divide by 3600 to get the number of hours, and then the leftover. Where are you gonna get the leftover from? Using the remainder, and then you divide by 60 again to get the number of minutes, and the leftover is the number of seconds left.
Okay, I got you.
Yeah. So this is all what you need. This is all what you need. Any other questions?
No.
That's all good.